Good morning, Algebra 2. Today's section is section 12-3, dealing with geometric series. And the essential question for today is, how do you find the sum of a finite geometric series? So when we talk about a sum of finite geometric series, we're looking at adding up a certain amount of geometric sequences. Now, before we get into this section, we need to go back and do a little bit of review. In the last section, we dealt with a geometric sequence. And there's two things we need to know for a geometric sequence. One, we need to know the first term of the sequence and the common ratio. When we have that information, we can go on and find a geometric series. So whenever you see the word sum of a finite geometric sequence, that tells us we're dealing with a series of a geometric sequence. So what we're doing is, in this formula here, is we want to find out how many terms, so n represents how many terms we're going to be dealing with, equals knowing the first term of your geometric sequence multiplied times the quantity of 1 minus the common ratio raised to the n power, which in this case, if we're going to add up 5 terms of a sequence, we're going to use 5 right here. So we're going to use this formula and an application of the geometric sequence to find a series. Now, while I'm at it, as a quick review, we can also do this with arithmetic. So here is the arithmetic sequence. Again, we need to know the first term of the sequence, and we need to know the common difference. Again, we covered that back in earlier part of chapter 13. And this is the formula for finding a series of arithmetic sequences. So we're trying to figure out, let's say we want to find the summation of the first 4 terms of an arithmetic sequence. Once again, you just need to know how many terms you're adding up. You need to know the first term of the sequence, and you need to know the nth term. So if we're trying to find the first 4 terms, we need to know what the 4th term of this sequence is. And to do that, we go back up and use these formulas up here, okay? All right, so with that said and done, let's go today and look at nothing but geometric series. So the very first page is, I highlighted what a geometric series is. The Explorer part, I'm not going to go into that. That's just getting you to apply geometric sequences. So let's go to the next page. The Explorer 2 is showing you how to derive the formula for the geometric series or geometric sequence. Well, once again, we don't need to do it. There's the formula. Get that into your HT&Cs, and we're going to apply it now, okay? So with that said and done, the first explain letter A, I'll let you guys go and read that. And what I'm going to do now is I'm going to throw letter B at you. And let's try to go through this one step by step, okay? Here is our sequence. We got 1/4, 1/8, 1/16, all the way up to 1 over 512. Okay, and we want to take and add up this many amount of terms. Well, at the beginning, we need to know what our first term is. We need to know what the common ratio is, and we need to determine how many terms we have. Now, this part right here is going to be the algebra part, okay? So looking at the setup, we know our first term is 1/4. We know that the common ratio is taking the second term and dividing it by the first term. Or you can do the third term divided by the second term. It does not matter. you'll still get the same value. So our common ratio is 1/2. Now the next part is figuring out what term 1 over 512 is. That's the next part. This one right here, I'm going to let you guys see it. I'm going to do an example in a moment. And I did all the hard work, but now we're going to go and do it together, okay? So you probably need a calculator. So let's go and look at our next problem, okay? I'm going to do the 2-year terms. Find the sum of the geometric series using this formula up here. Here is our geometric series. 1, -2, plus 4, minus 8, plus 16, minus 32. Yes, you could easily have gone into your calculator and figure that out, but it's a good idea to start learning how to do this because you'll see why in a moment. All right, right off the bat, we see the first term of the sequence is 1, or the first term of the series is 1. The common ratio is taking the second term and dividing it by the first term. We get -2. And we have 6 terms here. 1, 2, 3, 4, 5, 6 terms. All we need to do now is take that information, plug it into the series formula for a geometric sequence. There's the setup, and do your math. It's relatively easy. However, the hard part is figuring out how many terms we have. And I'm going to show you how to do that on the next problem. And a lot of that goes back to previous sections. All right, so number 7. We have 1/2 minus 1/4 plus 1/8 all the way up to -1 over 256. And we want to add up all these terms, which again, we don't know how many terms there are. So let's do it. So first things first, we know the first term is 1/2. We know the common ratio is -1/4 divided by 1/2, which we get -1/2. And the next part is how do we find out how many terms there are, okay? This is the part we got to go back and remember power rules, okay? So going back, using, again, if you look at the very first part here, this part right here, if we want to find out the term that we're dealing with here, so we want to find out what term -1 over 256 is, we have to use this formula. So a sub 1 is your first term of your sequence, r is your common ratio, and n minus 1. So we're trying to figure out what n is from this problem. All right, you with me? First thing we need to do is we're solving for n, so we have to do the order of operations. So we're going to multiply both sides by 2 over 1. That's where I got the -1 over 128. Multiply it by -1 over 256 times 2. All right. The next thing we got to do is, in order for us to simplify this, we got to get the right-hand side to have the same base as the left-hand side. So we have to do a little bit of thinking. So I got to ask myself, is 128 going to have a base of 1/2? Well, in this case, base of 2, it's true. So again, to figure that out, we could say, well, I already know that 2 raised to the 7th power is 128. So now I can rewrite the right-hand side to this rational expression. And now if you look at the problem, since the left-hand side and the right-hand side have the same base, a little bit of application of the one-to-one property, we know that n minus 1 has got to equal 7, and we just solve for n. So that tells us that -1 over 256 is the 8th term of this series. So now that we have 8, we just plug it into our formula. We know our first term is 1/2. We know our common ratio is negative 1/2. And we know n is 8. So we're going to find the 8th term. Now what I did is I try to do these problems step by step. I don't like to throw everything into the calculator right off the bat because you're going to get a mess up of a problem, mess up somewhere. You're going to say, where'd that come from? Because you messed up your order of operations. So the first thing I did is I know that 2 to the 8th is 256. That's power to a power rule. Then I know the next thing I'll do is I see the denominator here, we can really add its opposite. So I get 1 plus 1/2. Then the next part here is, here we don't even have to use the calculator. Well, I already know 1 is 256 all over 256, and you take 1 away, you're left with 255 over 256 divided by 3/2. Now the next part is, how do we go from here to here? Now again, I'll just show you my calculator. So again, close it up in parentheses, 255 divided by 256 divided by 3 divided by 2. And you're going to get a decimal. Now again, Bob is not going to have it in decimal form. Bob's going to have your answers in fractional form. So again, to get this to a fraction, you go math, frac, and you get 85 over 128. You multiply that times 1/2. Again, go to math, frac, and there you have 85 all over 256. So if we were to add up all 8 of these terms of this geometric sequence, making it into a series, it will be 85 all over 256. Now remember, Bob is not going to have this as a fraction. Excuse me. Bob is not going to have this as a decimal. So you calculator users, remember that. If you get down to your decimal representation, you got to convert it to a fraction. All right, so quick recap. We are dealing with geometric series. Shuffling my notes around, making you guys all dizzy. Again, geometric sequence, geometric series is this formula right here. And you may have to go back and figure out what one of the terms are in the series, but you have to go back and use the geometric sequence. Again, I'm hoping this will help you guys out. Try your hand at these. Take your time. All mistakes are made when you quickly just type numbers into your calculator. Think it through, and you'll do very well. All right, guys. Catch you later.